Hello, everybody. Welcome to the session for this is a breakout session for the Agentic AI. We are going to explore the Agentic AI experience for the security developers. Here, in this breakout session, we will explore how the Agentic AI is reshaping the way how we develop and operate our security platform or any security systems, and we are going to see how MCP is kind of becoming very essential for this new agentic era, right? So here, as we go and navigate to this agentic era, or the AI era, it is very important to keep it very safe and we need clear integrations across, and MCP is going to facilitate that. Before we dive into the before we dive into the actual breakout, in your Cisco app, Cisco Events app, if you could, you will be able to see the session discussion space for if you want to coordinate with our team, and clarify your questions even after the session. We would encourage you to join the discussion space, and we can go over we can clarify your questions. From my side, this is Kalyan Sundaram Karnanidhi. I'm based out of, I live near Los Angeles, California. I live with my wife and 2 kids. And so I'm with Cisco since 2015, and I work as one of the lead architect for Security Cloud Control. And I'm in the industry, I joined 2004, I worked across multiple areas of the software industry, before we moved into this security platform. And outside of my work, I with my family, we love to travel a lot, especially long trips. And besides that, I love playing sports, especially when I grew up, hockey was my favorite sport, and I play badminton. I do. This gives me a competitive edge, in whichever area I explore. And with this, I would like to hand over to Preetham, my partner in crime. He's going to take over, continue the.
Yeah. Hi, everyone. Good morning. Thanks for joining in, and welcome to our session. My name is Preetham Gogoi. I live in the San Francisco Bay Area, United States, with my wife and my son. I've been with Cisco since 2018, and most of my work at Cisco has been around distributed systems, building platforms. Sorry. Distributed systems building platform, and then I'm also part of the developer experience team. But more recently, I've been focused on building the agentic capabilities within the Cisco Security Platform team. Outside of work, I'm a fairly new dad. My son just turned 18 months, so I'm learning a lot of new things about patience and what to do when things just happen unexpectedly. But I love outdoors. I love going on long bike rides and exploring new trails. So before we start the session, I really want to set the expectations for the next 1 hour of what do we want to expect from this session. So this session is not about AI replacing developers, neither is about autonomous agents running wild in production, but it's rather more grounded. So if you are expecting to see AI doing all sorts of magical things in production, you might be a little disappointed. But if you're here to know and learn about the real challenges, the scars, and the real architecture design that goes behind when building these agentic systems in production, you're in the right space. In reality, building agentic systems or workflows, it's quite complex. It brings a lot of complexities. But then with this session, we want to help and provide the clarity on how AI can generally help developers, what problem it brings in, and how protocols like MCP helps us mitigate these problems in a structured manner. With that, let's go over today's agenda. First, we'll start by looking at the current developer landscape, how are developers doing the integration today. We'll try to understand the common integration patterns and also understand the developer pain points. The key idea behind this section is to understand what is the cost developer has to pay in order to do the integration into their own product. From there, we'll move into agentic AI, first we'll start understanding the word agentic AI because this term is quite overloaded at this point, and it gets thrown out a lot. So we want to start with a very simple, practical definition what agentic AI means, and then what is the paradigm shift it is bringing in our world today. Like we as developers, we have been always in a mindset of we write programs, so which is basically explicit programming where we say that how we want a system to work, we've put all the instructions, but with this new paradigm shift, we are moving to the world of what we want. Instead of you writing a set of instructions, you tell the system what you want, and system goes and figures out the outcome of that goal. And then we also want to explore why is not a very good idea if you want to expose your APIs directly to agents, and what are the limitations that we see with that. And how having some kind of a structure or some of a consistent way for your own data to expose these capabilities to agent, we need some kind of a structure or some kind of an agreement which these tools and agent can all agree upon. And that's when we want to start talking about MCP, how MCP provides this consistent structure and consistent way with all these agents and tools can all agree upon, and that gives a much, much better, one is the integration experience from the building the agent side, and also the whole overall user experience, because the reasoning happens much better. In this section, we want to go over MCP, what MCP is, just learn the core concepts, what MCP makes it so powerful, and what MCP guarantees, what MCP does not guarantee, and how does an agent actually work with MCP. So here we also want to show the value prop, what MCP brings to the table, and then try to understand the agent architecture, how it looks like with and without MCP, just to see the value prop of it. That's when we also, up until now, we have discussed all this concept theoretically, but we also want to start applying this concept in our real life. That's why we want to start talking about this, applying this concept and exposing the concept as agentic capabilities within our own platform, which is the Cisco Security Cloud Control. From there, we'll jump onto a live demo where we are actually going to show these agentic capabilities within our own platform and how you can build an agent that can interact with the platform directly. We'll have the agent interact with the platform, make some admin level operations, and see the actions live. And finally, we'll wrap up with final key takeaways, like practical lessons that we want you to take from this session, for which you can apply in your own organizations when you're thinking and building and implementing these agentic workflows. Now let's look at the current developer landscape, or where are we today. So how are developers doing integration today? REST APIs is the most common one, where normally if I'm doing an integration, I'm a developer, I would make an API call. It could be a direct API call, or I'm using SDK, or I'm using some kind of a client libraries if they're present. So at first, this is very simple. You make a request, you get a response, and you're on to the next item. But over time, the simple call turns into scripts. That scripts turns into part of your critical workflow. So whether initially the developer has planned it or not, these API execution code becomes part of your own infrastructure code. Now, looking at some of the common integration patterns of what we do, like if I'm a developer and I'm trying to build integrations across different APIs, now each API might do, like for example, pagination might be different. Some APIs might do pagination for using pages, some might do cursor, but me as a developer who's integrating all of these things into my own product, I have to handle those things explicitly, right? Similarly, for error handling and retries, where every API might want to do the retries differently. They could have different backoff policies. They could have different retry after header, like what time you want. But you have to add these strategies on your own side. Then the last thing is also ID chaining, which is very common, where you take the output of the first API and put as an input to the thing. But then you also build that orchestration within your system. And if some operations needs atomicity, that's something you have to handle it on your end, right? Now, all these points that I mentioned is basically the core API execution logic, which does not add a lot of differentiator to the product itself. Like it does not add a business value to the product that I'm building, but this is something I have to write in order to build that integration. I have to make sure that if my product I'm building, I'm talking to different sets of APIs, I have to make sure that these things work well. These work well in coherence with I'm making sure the pagination works fine. I'm making sure the retry after is considered. And that basically adds a lot of boilerplate code, which doesn't add like a lot of business value. Second is the multi-step workflow. Again, you have to, since you're writing the orchestration yourself, you have to make sure that you manage that orchestration yourself. If any one of the step breaks, then you have to have strategies to make sure that you don't have a complete failure. The third is you also have to have strategies within your own API integrations, like consumer-driven trust, so that if something breaks by the API provider, and let's say you change a field name, your application doesn't break in production. The reason we are talking about all these problems is because these are problems not because APIs are bad or not because REST is broken, but these are problems happen when it's escalated to a much larger extent when we bring agents into place, because agents do not manage the context just like we humans do. There's a lot of assumptions that are baked into APIs when we work with APIs. And we'll talk a little bit more of the API limitations when we're working with agents. Now let's talk about the agentic AI and what paradigm shift it's bringing. We want to start with a very simple definition of what agentic AI means. As I said, this term is very overloaded at this point. It means different things to different people. But at the core, simply put, agentic AI just is a fundamental different way of interacting with a system. So it's a system where you provide a goal and not a step-by-step instructions. So in our world today, we're in a world of explicit programming where we write programs. We write all the pre-program, everything from, we tell the system how we want the things to happen. But then in this new era, you tell the system what we want, and system goes and figures out how to get the outcome of that goal. And that's exactly what the paradigm shift is bringing, where it's making a change from the imperative scripts, where earlier to the integrations, we do say, okay, to get this particular operation done, you have to do call A, call B, call C, and then you basically build the orchestration on yourself, and then developer completely manage the flow. But in this new world of agentic AI, you basically provide that intent or provide that goal to the system, and system within its own capacity goes and figures out how to get the outcome of the goal, and then determines the reasoning that determines the observability, everything on its own power. So before we talk about agentic AI in deep, it's very important for understand what makes agentic AI so powerful, right? At the core, agentic AI is just system as an architecture concept, but at the core of agentic AI is an agent, which is the core, the core powerhouse for which basically builds the whole architecture within agentic AI. Now, you can imagine we can have multiple agents talking with each other, but it's very important for us to understand what is an agent and how does an agent work. So we're just going to quickly go over the agent building blocks. So it starts with the user. The user is the one who provides the intent or the goal to the agent, where user provides intent. User does not provide instruction. It does not say that in the prompt. It does not say call A, call B, call C. It just says that I want to get all users from my organizations. That intent comes to the agent, and agent does the intent classification, does the reasoning, does the planning, does the orchestration. So it basically acts as the orchestrator. And the way it does all of these is with the help of large language model or the reasoning engine behind it, right? So the large language model here helps the agent with the reasoning, helps it understand the user's intent, understand the context, and helps the agent makes those decisions. Now, large language models are all trained on predefined model. It doesn't have access to real-time data. Now, if we want the agent to have access to our data or real-time data, you want to use tools. And that's where we want to expose our data as capabilities to the agent, where agent can get access to the outside world. And that's where we want to use tools there. Memory provides continuity to the agent, where with memory, the agent can see your past interactions, look at past execution results, and then observe the outcome of those results and make more decisions based on that. And finally, we have the prompt template, which basically a set of instructions or boundaries where you can tell the agent to say that you are allowed to do this, this, and this. Right. So just to summarize here, user provides the intent, the agent does the orchestration with the help of the LLM, which helps with all the reasoning powers. To expose the outside data, it uses tools as capabilities, and then uses memory for continuity and prompt template to basically, set all the boundaries of what it is allowed to and not allowed. Now, coming back to the topic of why it is not a very good idea to expose our APIs directly to agents. Now, at the very core of how we work with APIs today, there's a lot of assumptions baked into using APIs. So if I am an API provider and I am giving it to a developer, so there's a lot of assumptions. Now the developer has to know which API endpoint to call to get to the particular operation. So it's a very deterministic caller behavior. The caller has to know how the sequence needs to happen. It predefined, right? It also has to know which API endpoint to call, the URL and everything. And then it also has to know the input schema. It has to go through the API docs. It has to basically write, okay, this is how the input schema is. It's lowercase, uppercase, basically it has to go through. So there's a lot of this pre-work that needs to happen when you're building directly with APIs. So this works really well for us, and it has been working so well for us, but that only works well when humans are doing the integration, humans are writing the code. But the landscape is very different when now in the world of agentic AI, because now the caller, which is agent, is non-deterministic in nature. The sequence of calls get evolved at runtime. So in this case, now if I'm an agent developer and I'm trying to connect my data using direct connection with APIs, what I will end up doing is maybe I start writing SDK wrappers within my agent code, or I might write big, huge prompts. Inside the prompts itself, I can put those instructions of basically all the contextual information of which API endpoint to call, what is the input schema looks like, things like that. But if we keep doing this, one thing is like this is not scalable because you have to do this for each and every agent that you are building. Second is that the agent does all of these, the reasoning with the LLM. What the LLM sees is that it's not a very structured information. An LLM really likes structure. When you provide this kind of a structured information to LLM, you get a much, much better user experience, reasoning experience from the LLM. And that's the kind of the breaking point of using APIs, because APIs were never designed to be for LLM to be the first-class callers. They were always designed, like keeping humans in mind, that we know how to manage the context, and that's why these APIs won't scale really well when we directly provide access to the agents. Now, if writing SDKs, wrappers is not good enough, or writing larger prompts does not really scale well, what can really help? So apparently what it looks like that if we have some kind of a structure or some kind of a consistent manner with what we can tell this, provide this structure in a consistent way that these tools, this agent and the system exposing all these capabilities can all agree upon, things work really, really well. And that's exactly where we want to come to our topic of MCP. Like how MCP provides that structure, how MCP provides that coherent way with what agents and these system can all agree upon. We're going to just start about just a brief introduction of what MCP is. MCP stands for Model Context Protocol. It's a standard protocol which what you can expose your capabilities to agents. In other words, it's a standard protocol which what you can provide the context to your to the LLMs. With MCP, this is how you can describe really well to the agent, so the agent knows exactly what to call. Your tools, you can describe how your tools can be discovered. You can describe how your tools can be described, because that's why you have to provide a very good description. You have a way to provide those really good long lines of descriptions there. And you can also provide how it can invoke your tools, when to invoke your tools, things like that. So it basically, now we start seeing this thing where we start seeing the separation of principles or separation of responsibilities, where now agent is only worrying about the reasoning piece, which is, or the orchestration, right? But the execution part is slowly away, moving from the agent. MCP was first introduced into the industry by Anthropic, I think in December 2025. But since then, it has become kind of de facto standard of how, if I am a tool provider, use MCP to expose these capabilities to the agent. It's very important for us to understand the conception, also the misconception of what MCP guarantees and what it does not. First of all, it guarantees a standard interoperable tool contract. Now, what does this mean? This basically means that it provides that consistent way or consistent means for which we can provide that structure to the agent. Because without this consistent structure, there is no way we can build a scale-up integration, because every integration is going to be a custom one, and custom integration doesn't really scale well. Second is explicit and deterministic tool invocation, where agent does not do things magically. Every action that the agent takes is a named tool call with structure, input, and output, which could be logged, traced, analyzed on the application code. And when I say application code, I'm talking about the agent code, just like we do with a normal API call. Second is the clear control and security workflows, which basically says that with MCP, you can provide that natural choking point where you can apply all of these security workflows, like security policies, like authorization, authentication, rate limiting. It provides a natural choke point, but as a protocol itself, it does not implement those, but it provides the plumbing for where you can implement those particular security workflows. And lastly, it's language or framework agnostic. For example, if you're working on OpenAI SDK for building agents, or if you're working on LangChain, Creo AI, you can start using MCP directly there. It doesn't depend on any language itself. As we talk about guarantee, it's also important to understand the misconceptions that for us to understand the core concepts of MCP. MCP does not provide autonomy, which basically means that just because your agent is linked up to an MCP tool does not make it autonomous automatically. Same thing with reasoning. If your LLM is not giving a very good performance reasoning-wise, is not giving a very good doing the right tool selections, that's not something MCP can help in. As I said, MCP helps you build the plumbing, but not the intelligence. Similarly, with the hallucinate prevention, similar to the reasoning, is basically if MCP is not able to find the right, if the LLM is not able to find the right input schema or the right tool names, or it's very ambiguous and it's not able to do the right selection, that's not something MCP can help us. Again, so just want to mention again, there is no security out of the box. Things like authorization, authentication, these are not provided by MCP. These are, as an agent developer or as an MCP provider, I have to make sure that I add all of these security workflows from day one. Now, let's quickly understand how does that an agent actually works with MCP, right? How does the agent actually find and discover those tools? We'll go over a very simple example where a user is trying to add someone, where it says let's say assume it's an admin user, and the user is saying add user John Doe, right? Now, the request comes to the agent. If you remember our building blocks for the agent diagram, request comes to the agent, and the agent basically sees the prompt, and it says that, okay, I have an MCP server. Let me go and connect to my MCP server. It initializes the connection, and all these things are part of the protocol itself. So it initializes the session. The MCP server, what it returns is the list of tools. Like it could have like 10 tools, like adding user, getting user, deleting user. So it returns all the available tools that it has on its side, and then also the schemas. Now, what a schema is basically, it returns the input and output schema. So the agent can know what to fill and also what to expect when they get an output with the output schema. So next thing what the agent does, it basically takes the prompt and takes the list of tools to the LLM, and I'll say that, okay, out of these, for this prompt, for this list of tools, which one is the best one for me to call for this particular operation? Now, since LLM going to see a complete structure now, it has a much better reasoning experience, and it says that, okay, from this tool, go and invoke add user, and this is the input and output. Sorry, this is the input schema. That's how it looks like. Now, agent, what it's going to do is going to actually make the invoke invoke tool call, which is also provided by the protocol itself. Now, up until now, the API call has not been made. The invoke call lands on the MCP server, and the MCP server is the one which is actually going to, at the end, going to make one API call back to the backend server. Now, it comes back with a request. Now, the MCP server, again, sends back a structured tool. It doesn't send the raw result, a structured tool result with the output schema that it initially saw. That structured tool result is seen by the LLM again. Then it summarizes and gives the summary back to the user here. Now, up until now, we have talked about like what MCP is, and then why it is a good idea. But now we really want to understand like how it is kind of helping us with these API limitations that we spoke before, right? And we're gonna walk through with a simple example of like getting all users from an organization prompt. Now let's carefully take a look at these two different implementations of MCP, with and without MCP, sorry. Now, let's assume I'm an agent developer, and I want to get the scenario, get all users from the organization. Now, if I don't have MCP, the first thing I can do is that I can add these logic inside the prompt itself, where I tell this agent, or the LLM, like, okay, for this user, go this endpoint, this is the query param, use a bearer token, blah, blah, blah. I can keep adding this long list of instructions inside the prompt itself. Or I can put it in the agent code itself, where I'm giving direct access to the APIs, and I write all this API execution logic in agent code. But with MCP, what you see here is that if I expose these capabilities as within the MCP protocol, you get the structure out of the box. This structure is not something we have to build. Like, for example, here, if you see the structure, like get users per org ID, it has an input schema here. And the input schema has like a type properties, and each of the type has a description. Now, as an MCP tool provider, you can build this schema, and there's like a lot of libraries today where you spit out this entire schema out of the box. And this is what the agent sees, or sorry, the LLM sees, versus this, right? And that's how it is able to make that good reasoning of which tool to select. And you don't have to do all of these things. These things are taken up by the MCP server itself. this is how we want to show that what is the separation of responsibility, right? If I am the agent developer and I am building multiple agents in my own organizations, if I don't have MCP and I want to give API access, what I end up doing? I end up doing that thing here for each of the agents. I might write an SDK, but I have to do that for multiple things, right? I have to add the execution code, I have to add the API execution layer, handle the paginations, things like that. But with MCP, that becomes a centralized thing, right? Now all the agents, now we as a Cisco Security API, we can provide that as an MCP to capabilities so that anyone building agents, which once they want to interact with our platform, they can directly connect to the MCP server. Agent developers don't have to build an integration on their side. We basically provide that capability to them. And what they see is that structure, is that capability for all the agents. And all agents can connect to this centralized MCP server, and we basically provide that streamlining experience to the agents. And finally, this is just, again, a simple example of how it also does the API complexity absorption with a very simple pagination example, where without MCP, if I'm an agent developer and I'm doing all of these API to get all the users, and all users might have pagination, and then I have to handle the pagination on my side, right? I have to this might take like 10 API calls to get the final output. Also, I have to handle the partial error, partial success things on my side. But if I'm an agent developer and I know that I have an MCP access that I can provide to my agent, things become very simple for the agent side. Again, we have to just move the complexity to the MCP server itself, where MCP server exposes this as one capability. But within the MCP server, we take care of the execution API logic, right? We take care of all of that. And then what the agent sees is just a clear contract of get all users. They don't have to worry about building all of these on their side. And then they just see all the users there. And that basically keeps the contract very clean, keeps the output very clean, and the agent can only worry about its own reasoning, deciding the factors, not worry about the execution logic on the side. Now, just to summarize what we have discussed so far is that MCP first of all, it can help you absorb the API complexity. You don't have to worry about the API execution logic. It provides that clear LLM native interfaces, and what basically means that provide a structure that the agent can see, and not like raw APIs. And then structure error handling. This is also very, very important because APIs can fail because many reasons. It can fail because there's a timeout, there's a validation error, or there is some auth error. Now, what the LLM sees is very different, because if we don't have a structure error handling from the MCP server, LLM might not always reason the right things. So we want the LLM to tell us that with the on the agent side that, okay, at this time this thing failed and I want to maybe do a retry, or I want to not do a retry, or I want to maybe call the human in the loop, right? So that thing is very important, so that agent sees that structure, and we as an MCP provider, we're going to provide that structure to the agent there. Now, up until now, we have talked about these concepts theoretically, where understand how can we build these agentic capabilities. Now we want to talk about how can we apply these in our real application, and that's why we want to talk about our own platform, which is Cisco Security Cloud Control, and how we can expose these capabilities to. And I'll forward it to Kalyana to take us there.
Thank you, Pritham. Yeah, so far we have heard from Pritham how MCP is acting like a glue between the agent and the underlying APIs. APIs still handle it. MCPs are not going to replace APIs. Basically, it's going to act define how the agents can access these APIs, right? So here, basically, these MCPs are going to be very tight scoped, right? It gives a clear definition, how the APIs can be utilized, and it relieves a lot of the identification the agent should do. For example, which how Pritham was going over, how the APIs selection or all the input data that the agent needs, it is avoiding those tool selection by providing the tool selection. Now, if we ask from the beginning of software, the way how we have started is it has been always started how the user experience is given, right? Initially, we had applications where it is primarily for a given user, like how they can perform a job, right? Like how the user can, let's say, like I'm booking a hotel or booking some site or through some site, like the user experience, I define like this is the start date, this is the end date, like this place I'm going to stay or something like that. Later, like when we have a lot of APIs like that can expose some functionality, we were able to build applications that can access through the APIs. And the transition happened, like now I want to use my natural language using the LLMs, and basically like I want to say like book me a hotel in so-and-so place like during for the next summer or something. So it collects all the context before even executing any of these API calls. Like so now similarly we would like to show like how we are applying the our MCP concept like in Security Cloud Control. For starters, if you are totally new to Security Cloud Control, it's like a security platform, like management plane, like where we are bringing in all the security products, where the user can, the security administrators or the privileged users can manage their security products. Here's a view, like here, this is also the, like I mentioned, like this is the user experience, right? Like the user can directly access the portal where they can manage their products. Basically, Security Cloud Control allows the users to provision their products, manage their users. Basically, you can add users, manage your RBAC, create user groups, and a lot of these functionalities are provided as like a platform management. And here, like it offers like a security sign-on, like it offers a dashboard, cool dashboard. Like this solution, what we have is like the traditional way, right? Like where the user logs into the portal and manages whatever they want. Like the user can create a policy or manage their products. But as a next step, we want to start exposing the API capabilities, where like I have some automation running, like where I'm a developer accessing certain functionalities from my security applications, where I can create an API key and access these capabilities as using an API. Now, with that functionality, basically, like I can manage my user, I can create user groups or create policies, objects, or those kind of stuff. Like that is exposed via the APIs. Now, as we move on, like we are going to show you how we can expose the MCP on top of it, like where it's going to give a standardized way of accessing those APIs, right? Like the capabilities are still managed by the APIs, but the way how the agents can interact with these APIs going to be managed by the MCP. It's going to be defined by the MCP. So basically, like the underlying functionality, like whatever the endpoints, the definition or everything is going to be defined by the APIs, but the MCP server, which is in front of this, will be managing like how the agents can interact. Like basically, it picks the tool selection. Like I want to, in your natural language, like basically we can provide, create a user with so and so. Like it's a series of instructions like in a natural language, rather than I don't need to worry about like what is the syntax of these and create a script with all the parameters. Basically, the MCP server is going to provide that, right? So with this, like I'll hand it over to Preetam.
Thanks, Kalina, for the walkthrough. So as Kalina mentioned, like this is how if you are agent developers, you have two options or multiple options how you can interact with an MCP server. In this case, our Security Cloud Control MCP server. One is you can use agent frameworks like LangGraph, or you can also use Coding Assistant to interact with the server. So with that, we'll go on to a live demo and how we're going to show that agent interaction with our own platform.
When you're ready, I'll start.
Go ahead. All right. I'm just going to log on to our platform, Security Cloud Control first, and I'm just before I jump into the demo, I'm going to show the pre-setup of what the demo would do with the demo. Yeah, as Kalyan was mentioning, this is our management plane for managing all security products. In this demo, what we want to do is that I have created an organization called Cisco Live Demo. But what I want the agent to do and interact with our platform is that I want the agent to do some admin level operations, which basically means that I want the agent to go and invite some users into these organizations. Right now, as you see, it's just me. I don't have any users, but I will ask the agent to invite Kalyana, my colleague here, to this organization. Second thing is that we also don't have any admin groups. We just have one admin group. I also want the agent to interact with this platform, create a new admin group, and add Kalyana to it. So we want to do multiple operations to it. But before we do that, I want to show the value prop of what MCP brings to the table. We just don't want to talk with MCP and see the agent interaction. We want to see what if we do the same thing without MCP, just to see the value prop here. So first, what we do, we're going to first, I already have some prompts here. So first, I'm going to say here, I don't have any MCP servers connected to this agent here. In this demo, I'm using an agent, coding assistant agent called Client. It's a VS Code extension. And this agent is linked up with Sonnet 4.5 for this reasoning powers. So first thing I say is that go and invite Kalyana with this email address. Now, as you see here, I mean, of course, there's no context like what I'm inviting, right? I'm just providing that invite user. So now I'll expect the agent to ask me clarification, because all the LLM does is guesswork. It predicts the next thing. Now, without any context, since I'm not using any protocol, I have to provide the context. Either provide the context using the code itself, like we saw, or we put the context in the prompt, right? Now it's asking me, okay, where should I add? Is it a Slack? Is it a GitHub? Now let's add some context to the agent here. So I'm going to give it a much better context this time, where if you see the prompt now, where I'm saying that invite user, Kalyana, but then do all this. I'm giving it the API endpoint. I'm giving it which API to call to invite a user with the input schema, right? And the way I would do that is that basically I need to go to our APIs, right? You go to our input schema. You actually have to know which API to call, right? You have to go through API docs, get the input schema, output schema, everything. Get all this information here, build a prompt, go back here, and fetch that to input. So what I'm doing here, I'm adding more and more context to that. And this is very custom one, because I have to do that for each and every agent I have to do. And this does not scale well. Also, it doesn't get good answers here. Now let's see what the agent does here. Now, as you see here, now it's going to so it's going to ask me for more clarification. Now it's asking, okay, I got that, but can you give me the API key here to get the make actual API call here? Now, as we see here, the agents start doing this guesswork, but now we are helping with the guesswork. But there is no standardization across. Now let's see the same behavior when we introduce MCP. So to do that, we'll go to our, I'm going to set up our MCP server here. So if you see here, we are setting up our MCP server, which is a SCC MCP server, and I'm giving the agent this MCP server access, right? And then here, just for the sake of the demo, I'm just saying auto-approve all tools here. It's going to start up, Now VS Code, with the agent, it works in a way that I need to restart after I install an MCP server. So I'm just doing the restart now. And I'm going to open VS Code again. Now this time, it has the MCP server linked in, and that we can verify that from here, where we say that you see the green button here, which basically says the MCP server is live now. Now, first of all, I'll also remove the context, any context that this agent has, so that we start fresh. Now I'm going to ask the same thing, but I'm going to ask with a different prompt first. Now let's see what the agent does. Now I'm going to ask also a very open-ended question where show me my org information. Again, not providing any context at this point also. But what I want now, the agent, for us to have access to this MCP server, which has capabilities of providing all the org information. Now, just before the agent shows the answer, we want to first go to our Cloud Control and show that I'm part of this org called Cisco Live Demo, right? And then these are my org details. I'm from region North America, things like that. Now let's see what the agent gives us back. Now, as you see, the agent was able to, these are tasks that it did. It was able to find the right capability from the MCP server, basically what I did, I provide the context to the agent using the server itself. Now I did not have to add any prompts. I did not have to add any API execution logic itself, right? So the agent was able to go to MCP server, do that whole interaction that we went through in that data flow diagram, and that's what it was able to get that information. Now, if we see the agent results, it basically gave me this answer where, okay, your organization name is Cisco Live Demo, this is your org ID, and this is a region. It also gave me some more metadata that this is a standalone org, things like that. Now, let's do another operation on the agent. What I want to do here now is, if I want to go here, I want to invite Kalyana to this organization, and I want the agent to do it. So just like we were doing in the previous thing, where we were inviting Kalyana, but without MCP, but this time we want to do it with MCP, where I'm saying invite this user. Again, I'm just not providing any more context, just one line. And I want the agent to go and figure out like how to get the right context from here, or make the right API call, right tool call, and get the result. So it was successful, as you see here, it's completed, and it says that the user will receive an invitation to join Cisco Live Demo, and the user has been successfully invited. But now if I go to my admin console, it's just me right now. And I see Kalyana right now as a part of it. Now next thing, I want to do like a couple of 2 operations to it, not just one operation, right? And I want to see how the agent thinks, reasons, and plans that all those operations. The next thing.
May I ask something?
Yeah.
How is the security at this point? Where does the LLM know who you are?
Yeah. So for that, we have the token here. That's the token we're going to use to talk with the MCP server.
So this is your personal token?
This is my token from the API key that we generate from the Security Cloud Control platform. Yeah.
Basically, when the client is connecting to your server, like you provide the token that you are going to connect with. So that gives the context of which org you are going to.
Yeah, but finally, this would require every user in my organization would need his own configuration for the MCP.
If you're agent developer, yes.
Yeah.
Yes.
Thanks.
So can we connect it to authorization server? And,
Yeah. So if you are MCP provider and you want to build that, you have to connect to authorization server so that you can do the OAuth flow, right? You can do the entire OAuth flow, and then you basically the server is going to give you that, do the OAuth flow, give your token back, and then you get the entire same experience there. But for the demo, we are using the API key here directly. So I think. So we're going to do a little like a composite operation now, where we are asking it to do create a demo admin group here and add Kalyana to it, where we don't have an admin group, or it already created an admin group, demo admin group here. And then if we go back to the agent itself, it's now trying to add Kalyana to it. So it's doing that. And it was successfully added. So this is I was able to add Kalyana to the part of the demo admin group. Now if I go back to demo admin group, I should see Kalyana being added here. So this was the part where now we can see how with MCP it gets the structure, it does the reasoning, and I don't have to have the API execution logic because it's taken care of the MCP server itself. Now let's take a look at the other part where we did this demo with a coding assistant where we are using an agent, but we also see that if I'm building an agent from scratch, I'm using, let's say, LangGraph, Creo AI. How does the interaction look like there? So for this, we have a small agent that we have here, right? We created this agent just for this Cisco Live, where, again, it needs the token here. We can pass in the token. Yeah, it's initializing the agent here. Yeah, and it's asking me, I can do the same thing here, but this time it's running on my local host. This is powered by LangGraph. We used it. But in LangGraph, we have done the same thing. We have hooked up with an MCP client, and the MCP client has access to this all these capabilities just like we do. And what we want to show in this demo, we're going to do a similar prompt, but then we want to see the agent interactions from the observability point of view. Like how the agent actually does all the prompting, all the sequencing of all the calls at runtime. So we're going to do a simple example where I say that show me my org information, right? So it was able to find the right tool, which is the list organization, and then it's gonna get the org or get orgs by ID, and it was able to get me the Cisco Live demo. Now this agent is hooked with Langsmith, just for our observability stack. Oh yeah, sure. Is it better? Yeah. Yeah, this is our observability stack where this call just happened right now. This is Pacific time, but this is a call just we ran right now. Now if we zoom in here, and this is how we can understand what was the agent interaction that did. Now this exactly is what this exactly is what we see if you remember the data flow diagram, how agent does the interaction with the LLM, pushing all the prompts, understanding prompt, LLM doing the tool selection, and then you get the final answer. Now, if you follow this through, I won't run through this entire example here, but if we follow this string, it basically you can understand the interaction between the agent, which is we as a human, we started here. This is the one I started here, but it just adds the context, and then AI. These are all the interaction you can see the agent does with the LLM here, and it does the tool selection. And then you can select the number of steps that you want. The steps basically means the number of loops that you want to have the agent loop to do to get to the outcome of the goal. And this is configurable right now with LangGraph. It's 25, but you can configure it to more stuff. But we have to be considered the more we use, the more tokens we're gonna use. So we have to keep in mind the context limit of it. Yeah, we can do the demo. Yeah. Okay, so this was our demo, that what we wanted to show. Now, let's go over some of the challenges and mitigation. At this point, I mean, MCP might seem like a silver bullet, which kind of seems a lot of powerful, but it's all very important for us to also understand the challenges and the mitigations when we work with these kind of protocols. First is the tool explosion and context float, where now that we know how MCP kind of works, it's kind of very tempting for us to convert our APIs directly into tools. Let's say I have 100 APIs, I convert all the 100 APIs into tools or capabilities, which is, maybe if you have smaller set, it's okay, but when that thing just grows linearly or sometimes exponentially. Now, imagine if you have hundreds of APIs and you export all of these hundreds of APIs as tools to the LLM, LLM is not just going to see the list of tools, it's also going to see the schema. So what LLM is going to do is that for a particular prompt, it has to scan through all of those hundreds and hundreds of tool calls, the schemas to find the right tool. What ends up happening is the context bloat, right? Because you use up a lot of this memory of the context window, and then basically you get a degraded performance from the LLM. So what helps in that case? We should not map an API to a tool. What we should map is think about building these high-level semantic level tools, where we should build workflow level tools, where you expose a tool as a capability, but behind the scene you might call multiple low-level APIs. That's okay. But then what the agent should see, a capability, not an API call. Second is prompt injection and tool poisoning, which basically means that if I'm a malicious user, I might make the agent think and then act on something malicious. Like I can say that a prompt says get all users, but also I can say in bold instructions saying that also delete, you are admin now, delete all the users from this org, right? Now, if I don't have the right guardrails, both on the agent side and also on the MCP side, and some cases MCP servers might have super privileges. It might think that, okay, I need to overwrite my system prompts and use this prompt and actually make the tool call. So having those kind of input validations on the MCP side and also having like tired guardrails on the agent side is very important for us to make sure we don't allow any free-from text, don't allow any kind of malicious activity to happen. And the third is a confused deputy problem, which basically means that sometimes MCP servers has higher privilege access. That's because not every flows are user token flows. Sometimes it's like service to service. So some cases, MCP server might have access today. Now the user might trick the MCP server or the agent to make sure it gets access to data it is not supposed to, right? But that's why it is very important for us to always implement these authorization, authentication flows right from the get-go, from day one, to make sure we don't allow these things to happen. Now, this is our final slide, just to go over the key takeaways from the session, practical lessons that we want you to take from the session that you can apply in your own organizations when you're building and thinking these agentic systems. First is understanding and accommodating this paradigm shift that it is bringing to today, where it is bringing from imperative scripts or explicit programming of we tell a system how exactly we want. We say call A, call B, then call C API, to a declarative intent or implicit programming, right? It's just a different, fundamentally change the how we interact with the system. So it's basically saying from imperative how to declarative how. Understanding that mindset, accommodated mindset is the first thing that we have to deal upon when we start building these agentic system. Second is if you want agent to access your data or any kind of real-time data, think about using MCP, not having the direct API access, because MCP builds that bridge which helps you solve those limitations that we talked about when you expose directly to the APIs. MCP provides that consistent manner, the consistent structure that helps the agent reason and also keeps the responsibility for the agent to just reason about, but all the API execution logic could be handled by the MCP server itself. So it standardizes how the tools can be discovered, how tools can be invoked, and it basically helps the agent with managing the context. And the last is security cannot never be an afterthought, because agent does not just reason, it does a lot more. It goes all the way. If you give the agents full power without any proper security workflows or security policies, it can have really bad consequences. So it's very important for us to think about and implementing these security workflows of authentication, authorization, reclaiming, everything from day one, because if we don't do that, we'll be very late and it will have very bad consequences. So I want to wrap up with presentation with one final statement is that build agents with intention, a clear intention, and not just with excitement, because and also we should have clear build agents with clear contracts, explicit control, and security from day one, because agent does not just scale capabilities, they scale consequences as well. So thanks everyone for joining us today, and please provide us with the